All right, good. We're recording now. So here's the new measurements. So I'm going to say, you can see my pencil is ready to write. So we're going to say, let the length, we have to finish this one quickly. Let the length AB now be, if it's going to be 45, let's put it to 90. So every measurement that we see, we're going to be twice the size. So it's kind of ironic, we're going to enlarge in the size. All right, 90. Right, let the length CD. But the one thing I want you to understand now, the drawing was purposely small or reduced so that when you enlarge it now, it could fit on your paper. But not to worry. So
weren't we doing reducing though?
Yeah, but we're doing both of them because I was saying the first method, if you can look at the diagram, you see where you have C prime and C.
Yeah.
Right? The C prime is the reduced, and the one that's larger on the outside that isn't labeled C yet, that's an enlarged example.
So, sir, this drawing that we're going to do now, we're going to reduce it, right?
Yeah, we're going to reduce it.
Okay, so you're going to write the lengths right now.
So I'm going to create a new length for you. Let CD now be equal to 60 instead of 30. All right, 60 millimeters. Let's let DA be 40. Let the length DA be 40. Okay, and let the length BC. Wait, my bad. Let the DC now be 80. BC be 80 millimeters. Excellent. Now just ensure that when you reduce it now, you make sure that it can fit properly. Okay, and the angle of DAB is still the same. Is 90 degrees. Let's go through the steps again. Let me go for my gray ink. Why isn't this not clicking? There we go.
So when we're making the 90 degrees, do you want us to use a compass or a protractor?
You can use a compass, yeah, because it's fairly simple. It's not like a specific angle where it's difficult. Because all you really do is just draw. But here's what: because you're drawing this inverse 90, just make it use a set square because it's simpler.
Sir, could you go up to the measurements again, please?
All right, I'm gonna go up. So you don't have to use a compass, right? Because it's just a 90 degree.
All right, thanks.
Yeah. So let's redraw this now. So we're gonna say this is gonna be our length A. Let's put A right here. A. It's gonna be our length B. B should be fairly bigger than mine. All right. Let's go to now D section. So D is at a certain distance. All right. All right, now here's good. So using Chirag's method, as he said from last class, which was brilliantly suggested, we can just use an arc, right? Adding the measurements. Let's go here. Let's use a green, right? So if we're looking from D to C, the arc distance is 60. So just put 60 millimeters on your compass. Swipe on arc. Should be a region out here. All right. Go to know your distance of B to C. That would be 80. Swipe on arc. That will give you your point C. See with this point right here. There we go.
B to C is how much, sir? 80?
Right, B to C is 80, right? Okay. Let's label this point C. Let's zoom in. And then I'll just connect all the points together. And that would be your shape. It's the enclosed quadrilateral. So let me just highlight the points. So we're going to highlight this point right here. There you go. All right. I'm going to draw a line in between now to show that I am going to reduce it. Wait, no, wrong color. Here we go. It's supposed to be gray. So construction. Excellent. There we go. All right, great. So now, here's what we're going to do. Using the line division from module 2. All right, let's go here. Going to be a special type of construction. Fairly lighter than the main line, but it should be a bit brighter than the construction. So use a construction. Use a line division. All right, and divide this line firstly using the ratio that was in the previous question. And let me give you the ratio. So the ratio given was 3 to 5 for the reduced drawing. It's given 3 to 5. So we're going to divide this section into 5. I'm going to say, for example, 1. Let me just notch some of them off. Excellent. There we go. There we go. I'm going to say 1, 2, 3, 4. All right. My 5. But remember, it's going to be 5 plus 3. So you continue on, say, extend it downward and continue the total divisions.
Wait,
So what's the length of that?
The length of AB should be this.
18.
The length of this line division should always be the same length as AB, and AB is 90.
Sir, I'm confused. Well, how much of the...
Or the angle?
Yes, sir.
The angle could be any angle, but we typically like to use 45. So a 45 angled distance from here. It could be any angle though, because it still remain constant.
Sir, how much arcs should we make?
All right. So if you remember from Cena 2 math, or Cena 1, I think, ratios, essentially, you'd find the total amount of it would be 5 plus 3, which would be 8, right? And then this is tell you that the first 3 out of it would be your division. So let's look at it. Let's go here. So we're going to divide this total line. Let me extend it to make it 90. So here will be the actual 90-degree line. I mean, the 90-millimeter line. Here we go. And you're going to divide it into 8 parts.
Wait, so 5 arcs?
All right. Look. Do you remember what a ratio is? Let's go back here. So go back to module 2 for me. Let's review what ratio was again. So if it's telling you that you're dividing a line, so let's just do one of the reduction first, because instead of me doing 2 of them once, let's do just the reduction first. 1 second. Let's take it step by step. All right. 1 second.
What are we dividing the line into, sir?
All right. Follow along with me. If you're dividing a line that has 3 to 5, right?
Sir, what's the line division? How much times do we need to divide the line?
A total of 5 times for the first division. And then now for the first 3 of that would be your line division here. But
Sir, I have a question. What's the angle that we draw the line at?
it could be 45, any angle that is just 45 or 30.
Okay.
Right? So instead of me doing the 2 divisions firstly, I'm going to just do the 3 to 5 first. So you're going to divide a 90-millimeter line into 3 parts. Right? Let's do one of them firstly. So extend it outwards. Here we go. And let's just firstly divide it into 5 parts. So we're going to say 1, 2, 3, 4, and this is the fifth part. Extend it back here. Then now the ratio says you have it to be 3 to 5. So you would count 1, 2, 3. Wait. My counting is very off because I have some red dots here. But it's essentially 1, 2, 3, 4, 5. So this would be the third one. 1, 2, 3.
Sir, I'm confused. Do we like divide it into 5 lines?
Yeah, so divide it into 5 arcs. So we're doing the reduction one first.
So if it's 90, then we have to divide 90 into 5.
Right?
Like that?
18.
Yeah. And then we just draw 518, like 5 lines, 18 millimeters.
Yeah. But remember, if you're doing a line division, the angle must be the same as to which one connects to the endpoint. So if you're drawing line division, let me show you. The angles here must coincide. All right? Hope you guys remember this. So we probably need to go over these just to ensure that you remember them. There we go. There we go. So all of the angles in between must be the same. Right? And something interesting happens now, because now that we have a ratio, for example, of this line AB 3 to 5, this point here, let me highlight it red. That's going to be where our smaller drawing begins. It's right here. So when you have your third division, so count from the top, you're going to say 1, 2, 3. Highlight the third point because the ratio was 3 to 5. Everybody understand?
No, sir.
So do we count the I have a question. So we have 3 spaces and 5 spaces and 5 lines, right?
Right.
So what were you saying about 3?
Right. So if you look on the ratio, it says that out of the 5, you're gonna select the third line. So you're gonna count 1, 2, 3, and highlight that third line right here. Is everyone clear?
Oh wait, we have to draw it to the shape?
Can you repeat?
We have to draw the lines to the shape.
Right, because after you draw the line division, to get the exact angle, you're supposed to copy this line, right, and place it at each division. Right. We're gonna need to go over these because you guys are forgetting the steps of line division. That was the first thing we learned. Remember where after you divide a straight line, let's go back to dividing a straight line. Right. So in the first class, I think it was the first class or so, we learned how to divide a straight line. So we're here. So we had a line like this, for example, and we said that we want it in a ratio of 3 to 5. So we'd say cut it 5 times. 1, 2, 3, 4, 5. But in order to do that, though, you had to use line division. So here's how you do it. You draw an angled line beneath, then you divide this into 5. So you say 1, 2, 3, 4, and then 5. Connect the fifth line to the end point right here, and then copy this angled line to each point, and that will give you exact divisions on the line. You guys remember that? So in other words, I would copy this angled line and place it here. That will give me my fourth on the line. Copy this angled line again. Give me my third. Give me my second. And give me my first. So in other words, we have now A to B that is divided into 5 parts. Do you guys remember this? So if I tell you that I want a ratio of 3 to 5 now, I would essentially count 1, 2, 3, and this would be my third ratio, 3 to 5. Because the third line to the entire fifth of the line.
So what, do we draw that third line of the triangle just darker?
Just highlight it, because that's where now we're going to start to draw our smaller drawing. Just highlight it with a little dot, just to remember it. Right? And here's what we're going to do now. Let's go back. All you have to do now, it's pretty simple. If you have, because remember, you're essentially just mirroring the drawing. If you have the defined drawing already, all you need to do, guys, is just to copy the parallel lines. Just create some parallel lines. Look at this on me. Create some parallel lines. So you're going to move this angled line BC and place it at this point here. Right? Move this angled line DC and place it at this intersection here. Right? You're going to label this point now your B prime. Let's go here. I'm going to zoom in really quick. Zoom and type B prime. This is going to be my C prime. My C prime. And this is going to be my D prime. And something cool happens. Right? This drawing is the exact drawing that we had originally, the A, B, C, D. Do you remember that drawing right here? The A, B, C, D. But this one now, let me highlight it, and it's going to blow your brains. It's essentially a mirror of the drawing we had before, but at a smaller ratio. Does that make sense? Did I lose you guys?
So what happened to A1?
Right. So now A1, yeah, you can just label A1 here, my bad. You really could just say that's A1 as well. But since it's the same point as B, we typically don't, but just for clarification, I'll show you that it's A1. You could say this is A1 as well. Because even though it shares the same point as A, it's still a defined region for the smaller reduction of the drawing. All right, so that's when you reduce a drawing. Does that make sense? Is it quite?
Yes, sir.
All right,
No, we have to like highlight the bigger one and the smaller one.
Right, so highlight the smaller one and the bigger one, right? Right? And now we're going to learn how to enlarge this drawing. What if we didn't want it to be for a toddler, want it to be adult size, for example, so want it to be a larger drawing, right? We're going to say now that we're going to create something called B double prime, C double prime, and D double prime. So what I want you to do now, you're going to take the same exact steps that we just did, right? But instead of 3 to 5, you're going to have a ratio of, for the second drawing, this is going to be a homework, use a ratio of 8 to 5. All right?
That means we draw 8 lines and then we start at the 5?
Exactly. Okay? So you essentially extend, create a construction line here. Somewhere along here, B double prime will be, since it's enlarged. So in other words, what you could do is just use the same exact division, extend it to, like, for example, the 6th, 7th, 8th, connected to the B prime. That will tell you where B prime is. And you just extend these lines as well. And that will be your enlarged drawing. That's going to be your homework. All right?
So can we do it on the same drawing though?
Yeah. It's going to look totally neat. So when you make all the drawings connected together, it's going to look exactly like how it looks in the book, where it looks neat. But ensure, though, that your drawing has different layers of construction, where, for example, this small reduced drawing doesn't take away from the enlarged drawing. So when you're doing it, ensure that your main lines have different levels. So this would be your most important main line. That's how I have it read. This would be your second important. Then no, the third one would still be in red as well, because that's your important one as well. So when you draw your third enlarged drawing, it should be highlighted more than the original one. All right? There we go. That's just a sketch of how it would.
Can you start using AutoCAD?
Sir, I sent you. I did on your on WhatsApp to you.
All right.
Can you check if that's right or?
Yeah, let me check it one sec. I'm checking. Okay, so I'm getting the feeling that you guys are gonna love this topic the most, because here's why. It's a case where now this subject, this aspect of it will lead us into AutoCAD. Excellent, Isaac. Excellent. Right? Let me just share the screen and show you what Isaac did. Sanjan has been in the waiting room. Oh my bad.
There's a waiting room, sir?
I thought I disabled it. I don't know why it's enabled. My bad, Sanjana. All right, let's continue. But the class is recorded. Thank you. The class is recorded. Good. All right, so look at Isaac's drawing.
How do we enlarge it though? Because at 5, we have to go to 8.
Right. So when I said 8 to 5, from the 5th region here, you're gonna enlarge it to say you have 3 more divisions. You're gonna say copy this line, paste it at 8, so forth, so forth, and that's how you get the 8th position from the 5th position. So good job, Isaac. That's good. All right. So now, but what I wanted to do,
Beautifully done.
yeah, but what I wanted to do now, Isaac, highlight the B prime, B double prime, C double prime, D double prime, and A double prime as your second enlarged drawing. All right, and then you're finished.
How dark are the lines? Do I make it as dark as the first one?
Yeah, make it as dark. All right, make it as dark. Mm-hmm. And then now, in hindsight, you probably should have had a little lighter tone for the construction lines, but I did say make it a little bit heavier, so that's my bad. But it is actually well done. All right. Welcome, Sanjana. I know you missed probably a couple minutes, but it's recorded. So we're just continuing from the class that we had earlier about enlarging and reducing quadrilateral. All right. I'll send you the video.
Okay, sir.
The video will be on the website, but let me just ensure that it's still recording. Yeah, it is. So you're just gonna watch that and just continue the drawing and finish it up. And then we're going into the second method, which is called direct method B. And as you can tell, this is my favorite topic in all of TD because the coolest part of it comes out. What if now you're designing, for example, a prototype of something? You want to design a machine. You can scale it down to a hand size, or you can scale it up to a building size using enlarging and reduction. That's why I really appreciate this topic. All right, so let's go into direct method B. Direct method B. So this question now is going to say that we have, let me just, all right, one sec. All right, there we go. Excellent. So we're going to draw now another quadrilateral, but in other words, we're using a different method. We're going to use a radial method. All right, so radial method. So in other words, let me just quickly give you a sketch. If I have a drawing and I want to enlarge it, like if I have a building, let's say I have a building right here, a beautiful building. There we go. Wow, it's an amazing building. I'd buy this one. There we go. All right, if I have a building, right? Essentially what the radial method says is that from one point, I can connect every line. Let me use construction. I can connect every line. Right, connect every corner of the drawing. Oh, my bad. All right, and something interesting happens. When I connect every single inch of this drawing to this line, if I want to reduce it or enlarge it, all I have to do is just extend these lines. Extend these lines.
Wait, sir, are we doing direct method or the radial line method?
Right, I'm just gonna go to the radial line method. My bad. Radial line method. Because direct method B is not a case where I need to go through it because it's essentially the similar thing to direct method A. But at another time I will go through it, but I think radial method is more important right now. Right? So what if now you wanted to enlarge in this building? All you would have to do is just copy the positions, right?
Sorry, but what is this? The enlargement and making it smaller?
Yeah, no, we're using, so we're gonna enlarge in firstly this building as a sketch and show you why radial method is so appreciated. Because, for example, I could be looking at a building and I get inspiration of making it larger. This is me, for example. I'm looking at it, and I could say I want to reach at this distance, right? All I have to do is just copy the lines, right? Copy the distances, and because of my perspective, the drawing gets larger as well. What if I want to make it smaller? All I have to do is copy the position again, right? There we go. And the drawing essentially becomes small as well. But this is a very bad sketch. I hope you get the idea. And now we're going to actually do it now.
We're using the same shape as before, right?
We're going to use the same shape, but in a different position. No, the same shape. We need the same shape.
We're using a different method, right?
Yeah,
So
so
this radial line method, is this homework or are you gonna do it now?
we're going to do it now. We should be able to knock it out now in 10 minutes.
Could you give a minute just to like title the page and stuff, please?
No problem. But let me just write the measurements quickly. So we're going to say now that we're going to firstly use the same drawing, because that's probably a good step. Use the same drawing, right? So we're going to use the previous drawing and all of its measurements. And all of its measurements. All right, let me just begin it. So let me just quickly.
So are we reducing or enlarging?
We're gonna reduce it first.
So we have to draw the big drawing, right?
Yeah. So draw the big drawing naturally, and then now you're gonna put a point anywhere here. But let me just go for the measurements quickly first. 1 second. All right, so let's copy these. Control copy. Let's go to radial line. Okay, so using all of these measurements, right, you're gonna just recreate the drawing as exactly as it was. Let's go here, construction, and it should look like this. You have A, D, B, and then you use the arc method again to find C. Right? C would, for example, give you an arc out here. So it'd say, for example, D.
Sir, did we choose a random point for
Yeah,
D? Like
that's the cool part of it. You choose a random point. Okay? Right, but before we go there, let's quickly just draw this first. So we're gonna say this is D. It's gonna be A and B. Right? You use an arc to say D to C is 60. So use an arc of 60, swipe an arc. B to C was 80, swipe an arc. There you go. And then you just highlight the drawing itself. Let's go here. So we have A, B right here. Excellent. Right. So now the first step to this radial line judgment is you're going to declare a point P. Declare a point called P. Right? It should be conveniently at a position that's outside. So let's say, for example, declare it right here. You can declare it right here. Label it P. All right. Now, what you are tasked to do, and I say task because if you don't do it correctly, it's going to affect the entire drawing. You're going to create something called a
How far back should P be?
Convenient. So just make it a good position out of the drawing. All right. Let me just go to yellow. Let me use yellow. Now we're going to connect this point P to every vertex or edge rather of the polygon or quadrilateral that we had. So I'm going to go here, connect it to A, connect it to B, connect it to point C, which I should have labeled. There you go. And also connect it to point D. Yours should be again in construction, so it won't look as disruptive as my colors. Right? Then now, let's write the steps. You're going to now divide PB into 5 equal parts and label the divisions. Same as you did
Sir,
before.
and angle can be anything, right?
Right, any angle. Okay. Let me go on red since I haven't used red yet. So PB, the entire distance you would have measured firstly. Right. So let's say, for example, this is a region of, depending on your point. So let me write that first of all. Depending on your point, depending on your position of point P, your distance of PB varies. So if you put your P far back, your distance PB will be a large value, right? That might be good in some cases and some cases might not, but it doesn't affect the drawing, right? So when you find that distance, let's say, for example, mine is 100, I'm going to divide that 100 into 5 parts, right? Let's quickly notch. We're going to say, for example, the first decision is here. 2, it's probably too small. That's good. All right, let me erase that. I'm going to say the first division is here. 2, 3, 4. All right. Now, when I have those 5 divisions, right, you have to remember it's a line division. So you're not going to create these divisions like how I just did. I'm just cutting the step short. You would have created the angle first, right? You could have created so whenever you use your angle, that's your construction box, for example. So you'd have created the angle, connected it to the point here, then moved this into a division of 5. I just cut it short, but I won't do that again because I want you to make sure you do the steps. Right? Let me divide it quickly. So say 1, 2, 3, 4. Then you move the position of this angled line to here, and you'll find it will create this point here. Right? Now the biggest issue that some students have is remembering to label. Right? So if you have a point PB, when you create the enlarging or the reduced size, ensure that you have labeled, like for example, B prime, A prime, D prime. Because if you don't, then how would I know that it's another labeling or another reduced drawing? I would just think you just created some lines, right? So, right, so here's what we're going to do. So now we're going to say, after we've divided the line into 5 equal parts, we're going to say, let's go up, label point 3 B prime and draw A prime and draw A prime, B prime parallel to AB. Right, so this would be point B prime. Right, let's label it. Right, and you realize that my line is going to be thinner because I want to show the difference. B prime, there you go. Right, and what I'm going to start to do coming next class, I'm going to do something called a virtual host. Right, so I'm going to have one of my devices drawing this on AutoCAD for you, and I'm going to explain it while I'm doing it because this drawing now is starting to get technical, and these sketches really can't provide the description I want. So I'm going to start to use AutoCAD to explain it after this class. Right. So now the task is to connect this B prime, right, to A, right? But you need to have it parallel to AB. So what you're going to do, you copy this line, draw it parallel. You realize that it creates a point here, AB, A prime. Should be in green, my bad. But I'm pretty sure some of you guys are even finished already. Because you're awfully quiet. There we go. Okay. So the next step for the other corners. So the reason why I write out these steps is that if you don't have the book, I will just give you the notebook and you just find the steps here easily. Just let me know if you don't have the notebook yet, and I'll just give you the link. All right, for other corners, B prime, C prime, and D prime, right? Lines are drawn parallel to the original figure as before.
What measurements?
Sir, how? Oh,
There you go.
sir, how do you get A prime?
All right, let me explain that again. So after you create the third division as B prime, you take a parallel line that was AB and place it at B prime. Wherever it touches the line that connected to A. All right. And let me just quickly wrap up this because I know it's a lunchtime. All right, so let me explain how you got the line A prime. So you got the division of B prime, correct? Are you there?
Yes.
Right? All you have to do is take the parallel line that was originally AB and place it at B prime. Wherever that line touches the point from P to A, wherever it touches here, that's going to be called your A prime. So it's like a mirrored effect. Understand?
But then, sir, will it? Oh, we're doing mirroring, sir.
No. I was giving an example that's really what's happening. You just replicate or you copy the exact lines and place it on this B prime wherever it cuts this line that was created earlier that you connected from P. You remember that?
Mm-hmm.
That would be your A prime.
So basically, so we're doing B prime from the second line, from there.
Right. So when you created a division, your B prime would have been the third division because it's 3 to 5. Remember that in the first one we talked about 3 to 5? That's what we're doing here as
Yes,
well.
sir.
So we said 1, 2, 3, B prime. Parallel line of AB, place it at B prime. That gives you A prime. Here's the interesting thing though. Since we want D prime and C prime, what do you think we're going to do?
Sir, make it parallel, but I was gonna ask what measurement do you want us to do that as?
So here's the thing though. You don't need any measurements because as long as you stick to the rule, if it's a line BC, you're going to copy that line, place it at B. Wherever it touches the line that was connecting to C, that's C prime. So you don't need any measurement. Understand?
Oh, it has to touch the base of AB, then you're...
No. It has to just intersect with the line that was originally connecting to C. So you essentially this line could have been extended to wherever, but the point at which it crosses this line right here, that's C prime. So remember.
Sir, I did it.
You finished?
Yes.
Excellent. But let me just finish this one. So when you find C prime now, copy the line DC, and I want one intelligent person to tell me now, where would we stop as in regards to where D is? Anyone?
Wait, sir, it has to be touching?
Touching. Can you repeat?
It has to be touching that?
No.
This kind of looks different on my paper than on the screen.
It has to be different because remember, I'm just sketching it. But essentially, did you create your points P to A to B and C and D?
Yeah.
All right. Did you then had a line division at PB where you said 3 to 5?
Yes.
Did you copy a line AB and place it at B?
AB?
Yeah,
what
so
do you mean?
This horizontal line right here, let me use red because teachers love red ink. And I bet you know that you understand what I'm saying because I'm using red ink.
I did it like...
So this
Can
line,
I send you a picture of it?
Yeah, so this line right here, just look at this for me. Right, you see this line? This.
Can you please see? I'm not sure if I did
right.
what was right.
Let me go on your drawing. So everyone, let's look at my screen. I'm gonna go on Harshita's drawing. 1 second.